Tiger files, which allowed you to do address coding, right? Put in an address and estimate its location. Okay? The Census Bureau doesn't get enough credit for that, but they were real pioneers in doing that. And the fact that that was public domain, right? People could go grab those. A company like ETAC, in 1985, the first automated car navigation system. MapQuest, 1996. This was a PhD dissertation, essentially, at Buffalo, where I did my undergraduate and master's degree. And then, and one of our students was very much involved in this. And they sold that to AOL for $100 million. Pretty good. You can't overemphasize the importance of having powerful computers because we have a lot of data. Big data is part of the theme of what we're talking about today. But Moore's law is kind of interesting. And I started really studying this, So the actual definition, the number of transistors in a dense integrated circuit doubles approximately every 2 years. Well, look at that bottom line. The iPhone 5S produces 76.8 gigaflops, nearly 1,000 times more than a Cray supercomputer. Okay, I remember Research Triangle got a Cray supercomputer. They had the head of the Office of Science and Technology from the White House came there, and he had this big Cray computer, and it sat in a bed of liquid nitrogen. So, can we do GIS? Can we handle large amounts of data? Sure. This is kind of fun, isn't it? So these personal nav systems, I'm sure you've had that situation. Go either way. I turned mine on one time when we were flying across the Atlantic, and I was going 466 miles an hour. So let me try to put some context to this. So in terms of data capture, back in the old days, we had existing maps and we digitized those things, right? And we did it, then we could do it on screen. Then we did field data collection. And now we do a lot of automatic feature extraction from imagery. Instead of doing things in situ, we do it remotely sensed. The public got involved, then commercial, and then volunteer people. Static to real-time sensors. The computing environment, we did things for Senator Hollings because we had an IBM mainframe. It's the only place you could do. The only place you could do GIS in our state was here. So we did it. Okay, but then we moved to workstations, we moved to personal computers, to GPS-embedded smartphones and tablets. The software, as I showed you, my initial GIS was a bunch of Fortran routines with CalCount calls. So we moved to full function toolboxes to on-demand services, which I want to get back to. Technical manuals. We used to have 12 feet of manuals, right? And now if it isn't intuitive, forget about it. Right? Nobody wants to go read a manual, right? Proprietary to open source, and our department here does a lot of open source stuff. That's a big deal. The data sources have moved from vector maps to precise high resolution imagery, 30-meter variety. You guys don't know about this. Aircraft, 4-inch vertical, drones, small satellites. We'll go back to that. The data models kind of moving from layers of data, okay, and trying to integrate those things to geographical objects, right? 2D, 3D, 4D kind of things. We were always limited by how big our hard drive was, right? Just always had. I bought the first personal computers at this university. We were going to buy word processing machines. And I said, no, buy personal computers. Right? And I placed the first order for IBM personal computers at this university so that every secretary in every department of our college could have an IBM personal computer to do word processing. Okay? But we were limited by the size of that hard drive, right? And now we have cloud where that just isn't an issue. So we look at this cheap storage and clouds of, $25 a terabyte, 0.2 cents a gigabyte, or you can rent cloud space from a variety of vendors. The competition is fierce, right? So you run out of space. Jack runs out of space at Ezra. He just goes to Amazon and gets more. Can you understand what Amazon, 50,000 new employees at Amazon? And these aren't people handling freight. These are people doing interesting things. 50,000 new ones. Anyway, okay. So who are the users? And I call it kind of technician-driven, chauffeur-driven GIS. Let me tell you that when we generated when we had the first ARC info things, Lynn Shirley was my driver. I was the chauffeur. Okay? And now I do all my own stuff, right? So that evolved from when we had to have technicians to the point that anyone can do it. Application scientists to managers or decision makers. A third generation spatial data infrastructure, all those things in Washington. It's all about spatial data infrastructure. Moving from products in which we produced hard copy maps until we have some kind of virtual things. I want to talk a little bit more later about service-oriented architectures. And then the relationship to the IT. A lot of my work this year is dealing with maturity models. So how does GIS fit into the larger context of what's going on at the university, or Richland County, or the state, or the nation, or the world too? I mean, huge GIS activities taking place at the UN right now. So in many cases, and I have a number of stories I can tell you, where the GIS guy did a good job, girl, in many cases girl, and became the IT manager. That happens often. Okay, so let me jump ahead here. The whole user interface, I showed you briefly that DIDS thing. You could put in some things on a manual. Text to now graphical user interfaces. Specialized graphics terminals to broadband connected personal computers without wires, right? The Web 2.0 stuff. Let me jump ahead here because I'm going to run out of time. These are things in the last decade that I didn't, that I followed. These personal navigation systems for under $100 to know exactly where you are. NavTech, a nice US company right out of Chicago. NavTech was purchased by Nokia for $8.1 billion. And then recently, Nokia sold that to a company called Here. Here are all the German automobile manufacturers. Right? So it's kind of interesting. So we start with the Census Bureau Tiger files, then we talk about road networks, and we talk about US companies, and now it's the German automobile. But at the same time, Apple and Google are just producing their own. The Google Earth, Google Maps stuff is the fourth major innovation in computing. I'm not going to go into it. Start with text processing, email, the web, and James Fallow says the next big thing, the fourth thing that impacts people is the spatial stuff. Right? So it's now ubiquitous. And 77% of people who have a smartphone have a GIS app. Right? When you're asking Google, how do I get from here to there, you're doing GIS on a smartphone. Okay? Zillow, I held a parcel summit in the National Academy of Sciences. We brought the guy from Zillow there. You know Zillow? You know Zillow? Zillow, you want to find out the estimated price of your house, go to Zillow. They have 110 million properties, and they estimate, even if it's not for sale, they estimate the value of that. I'm standing next to the head of the Geography Division of the Census Bureau in 2007, and he says about the guy from Zillow, he says, they should be running our country. Absolutely true. OpenStreetMap, volunteer geographic information system, location-based social networks via cell phones, the iPhone as a field data collection device, the work drone, and I'm going to jump ahead to a couple things. So the whole street thing is NavTech and TomTom, good American companies, now kind of absorbed by the people in the Netherlands and Germany. But Google and Apple said, screw it, we'll do it ourselves, right? Instead of leasing somebody else's data, they collect their own. These whole small satellites and drones, and the parcel stuff I gave the federal government a deed. This company, CoreLogic, has produced their own version of parcel data for the country. But it's in the private sector,
7 different federal agencies license parcel data from a private company. And that's the truth. Okay? Travel is this kind of vertical market, where, I've got an app for that, how it's spatially enabled all kinds of things. Here's some crowdsourced real-time stuff in Texas. I did some consulting in Texas last year about why they need state-level parcel data. And they hired a guy and they're doing it. Social media, emergency preparedness, the real-time data feeds are really an important thing. And I was very pleased to see my last master's student, Cleo Andrus, has just written a paper called Integrating Social Network Data into GIS. She's now a professor at Penn State. She left here and went to MIT. But Cleo's out front on that social network stuff. Here's a great example. Here's a map in Kinshasa, Congo, that was generated by volunteers. That's the best map that exists. Okay? It's a huge market, now estimated at $13 billion a year. The drone stuff is just incredible. Charlie headed up the U.S. consortium on drone stuff. Where we're talking resolution in the inches, right, and various types of sensors that can be business. This whole thing about here, and this whole business of autonomous vehicles, right, where the car becomes a server, right? The car will become a server, okay, and estimate. It's going to be a lot safer to have autonomous vehicles than having drunks and other people driving cars. Right? Some of these public-private partnerships. I did this talk last year at BYU, and they had just formed a relationship with Google. So the state partners with Google to get imagery. That's my house on the right, my swimming pool actually. So 6-inch imagery, right? And you can go in there on the bottom. It shows you how you can actually correct that data. Really interesting stuff. And of course, all of the issues about privacy, and I could go on and spend a week on privacy issues. I don't want to do that right now. But clearly, a lot of activity with respect to protecting individual privacies. The LiDAR stuff, as I said, John and I were doing LiDAR stuff 15 years ago. But this is Central Park in New York. It's kind of a neat one. Of all of the kind of LiDAR examples that I've looked at, this one impresses me the most. You see the penetration through the tree canopy, and you can see the actual landslide underneath that. That's pretty dramatic, right? That you can penetrate through the tree canopies. This whole integration of CAD, BIM is building information models in GIS. This is University of Washington. They're doing wonderful stuff up there. My son lives in Seattle, so I visited the people at UW. Just incredible stuff they're doing. You may not be aware of this. Charlie, you might not be aware of this. Kevin, you might not be aware of this. There was always the AutoCAD people, and then there was the GIS people. Now look at this. Esri and Autodesk are hugging one another. What did the president say last week? They got the embrace. Okay. So this is kind of interesting. So GIS and CAD are now integrated, right? And there's no better example than the fact that this is Jackson Hartsfield Airport is a GIS application. That's pretty cool. This whole business of using your smartphone for data collection, huge deal. Now here's some recent events, like stuff that really is interesting. Planet Labs, right, produces little satellites. They take little satellites. A satellite is now a commodity. See up on the upper left? It's a commodity. It's a little box. And you can put different things in it. Okay? And then you can hire some nations' satellite launching rockets and put them up there, and you can produce swarms of satellites. Now look at this. Swarms of tiny satellites. Satellite images of North Korea show landslides at nuclear sites. Little sadly, it just totally disrupts the federal, like the Landsat program, right? So we get to a situation where we want answers on demand. Ubiquitous, interior, exterior, real-time, absolute precision, okay? Let me jump ahead here. And there are some people playing in our little sandbox that haven't been there before, and clearly Google and Facebook are major players. Mark Zuckerberg wants to find every residence in the world, and he wants to put a drone flying over them so they can have network connectivity. They have the resources to do it, don't they? Google thinks they can do balloons. Okay, kind of interesting. I saw this one day, centimeter level GPS on a smartphone. It's just going to be a new next year. Centimeter level accuracy on your smartphone. Okay, a new different way. Significantly more detail and true ground absolute accuracy. If you're driving an autonomous vehicle, it's got to be immediate, it's got to be highest possible resolution. That's going to happen. Okay, what is this map? What is it, a map? Come on.
The imprint of geology.
Population. All right, no guesses? It's not population density, is it? It's a map of every building in the United States generated last week by the New York Times. Every building in the United States. Okay? It's really fun to look at it, you know. If you haven't done it, go out and find it. Because you see, like, here's Columbia's on the upper left. That's awesome. On the upper right is like Grand Rapids, Michigan. You see the township and range thing. Or on the bottom left, that's Washington, D.C. On the right, it's suburbs of Arizona. Every building in the United States. Okay, that's kind of fun. New York Times. These guys have really got it together. Within 24 hours of the hurricane in the Panhandle, okay, they had drone coverage mosaic together. You see that one, you know, that's well known, that one place that had built well above existing building standards, and it survived. But they also, within 24 hours, they had the parcel data, they had the buildings, and they knew which ones had been damaged. Pretty good. This one's interesting to me, big data. As I say, big data means that, or cyber GIS, means I can no longer do it on my desktop. You might not agree with me. I challenge the people who are doing something. Okay. Now, look at this one. This was in The Economist. This is lightning density. Why are there more lightning strikes over the water than over the land? And they conclude that it's the pollution from the ships, okay, that are disrupting the atmosphere and leading to greater number of lightning strikes. Pretty interesting, isn't it? I thought so. Cyber GIS, this kind of national water model. A good friend of mine, David Magman at the University of Texas, has been involved with making sure we can do real-time, precise water models of the country. Okay? Another thing that we did see, there's a field called GeoAI, artificial intelligence, right? And another thing that Esri has just done within the last month or so is formed a relationship with Microsoft. Look what he's just done. He goes and partners with Autodesk, his major competitor. He partners now with Microsoft, who's tried to buy him many times. Okay? Emerging interdisciplinary scientific field that harnesses innovations of spatial science, artificial intelligence. So a lot of this kind of neural network stuff, we were doing that stuff here, again. 10 years ago, we had many a thesis and a dissertation that dealt with machine learning and neural network analysis. Kind of interesting stuff, okay? So here we're trying to extract information
Okay, can we generate some, an artificial intelligence built by this researcher at Carnegie Mellon to try to determine the value. Can we look at imagery and estimate the value of that neighborhood? I was very pleased to see that people in our department, Mike and April, are involved with cyber GIS, parallel cartographic modeling, a recent article by two of our colleagues. This gets us into the center here, the center of excellence on big data in coastal areas. And I look at these people, look at this rogue gallery of people here. Former colleagues, Dwayne Porter there was one of my early PhD students. He's still doing very well here. But anyway, there's a new consortium here. I'm very glad to see some of that taking place with partnerships around the world and various strengths of the department coming together with some very interesting modeling taking place. So I applaud all of you who are involved in those wonderful things. In searching around for what's kind of big stuff, I told you my grandson is doing a spatial data science degree at University of Oregon, undergraduate, okay? I found this the other day, spatial data science at University of Chicago, Susan's alma mater, okay? So this is a big deal, spatial data science, okay? Now, let me zap through do I have a few more minutes? I'm going to run out of coffee.
There's more.
Okay, I'm good. Now, let's switch gears. Okay, so you got some sense, right, of how we've evolved over 5 decades, right? So now the stuff is ubiquitous. You do it on your phone. You know, you need additional data. You go out and get it. You know, a whole variety of things. You know, so it's very intuitive. Now, I want to talk about ArcGIS Online and story maps because I spent a lot of the last year doing this. ArcGIS Online is a way of, and it's all web-based, so we're not talking about installing software on your computer. We're talking about opening up a browser. Okay? ArcGIS Online allows you to insert data that other people have contributed, okay, from the cloud, right? 1.1 billion map layers are out there for you to use, okay? Some of them are interesting, you know, and then there's this other thing called a living atlas. The living atlas is really interesting. Again, contributions that are being made, so we can share this. 3,658 layers of information, okay, that are out there in the cloud. You bring them into your application. You can do a variety, you can explore the world, right? This famous example of the difference between North Korea and South Korea. Demographic data. This is really interesting to me, okay? I showed you a little bit about the geospatial revolution and resources targeted for 7th graders through 12th graders. This is in the UK. Now the UK, a little different. Jerry, you know this, that, you know, they really take geography seriously over there, right? They take it really seriously. Well, Jack Dangerman has said a couple of years ago that any school in the United States can have ArcGIS Online free. That means he's establishing server space and other things. So any kid can do it. Any kid can do it. He also made this available to the British schools. In 1 year, 1,600 schools adopted ArcGIS Online. And then they build modules relating to it. Okay? So ArcGIS Online provides access to a lot of data layers that people have volunteered. This one is interesting to me. I searched for parcels the other day. Here's the parcels in Charleston County down on the Battery, right? So who owns all those big mansions? An interesting question. You can add little markers and things so citizens can build their own data and report instances of things, right? You can get real-time data feeds. This is weather data. You can link to various sensors, right? So I found a stream gauge, but now I can go to that stream gauge and get real-time data. Now, this is absolutely true. In preparing for this talk, I said I better learn something about this because I'm always a desktop guy. Right? So I said, what can I learn about GIS from ArcGIS Online? start to finish, 10 minutes. I brought in my own data, some apartments that I had collected from my District 2 stuff. I developed density or hotspot stuff, and I generated drive times, all through a web browser. No software installed, piece of cake. Right? So we get an example here where ArcGIS Online becomes part of a larger system, and then you develop web applications, and those things can go out to your personal computer, your tablet, or your smartphone. Okay? Now, let's talk about story maps. So story maps become a derivative of that. You can package stuff. 700,000 story maps are now hosted at ArcGIS Online. This is last week's data. 300,000 of them in the last 12 months, 2,000 a day. 2,000 a day, new story maps, okay? So, very simple templates. This is so I wanted to learn, can I make my own? How long would it take me to make a story map? 10 minutes, okay? That's my family, right? So those are all 9 family vacations. So, right? But I put that together into a tour, right? So you've got applications that are map tours, journals, map series, swiping, spyglasses, right? And kind of basic stuff. And you can, the number of examples is huge. You just go to Esri story